Right.
Okay, Assalamualaikum and good morning.
Okay.
Okay, Prof, okay.
Right. Okay.
Dengar okay?
Yeah, yeah.
Okay.
All right.
Okay, okay. Okay. I'm Siti Fatimah Abdul Rahman from Institute of Nanoelectronic Engineering. Okay, today I would like to share about microfluidic. So, first of all, I'm going to talk about a brief definition about microfluidic. So, microfluidic is the technology of fluid manipulation in channels with dimension of tens of microns. So, the idea of microfluidic is came up from the lab on chip, which is integrating entire biological or chemical laboratories in a single chip. So, this is how microfluidic come up. Here is the microfluidic channel. You can see here. So all integrated from chemical or biological lab can the benefits or advantage of microfluidic is require small sample volume, high throughput, and it low cost because it's only need to use the PDMS and some chemical. No need for another equipment. Okay, then short analysis time because it's like continuous on the single chip. So application is broad, starting from chemistry, engineering, and also life science. So how to create a microfluidic device? Okay, actually microfluidic is in a micro size. So the microfluidic channel need to fabricate using microfabrication based on the semiconductor, which is from microelectronic technology. So basically, there are two common lithography process, which are photolithography and soft lithography. Okay, to make a microfluidic, first we need to fabricate the mold first, and then we have to replicate with the PDMS. This the microfluidic PDMS. So what's the meaning of photolithography? Okay, photo is light. Litho is like stone or something hard. And then graphy is written. So photolithography means we transfer the pattern using UV light on the silicon wafer. Okay, next the soft lithography. We using the mold to make a chip from PDMS layer. So why I choose PDMS? So this one PDMS microfluidic device because it low cost, biocompatibility, low toxicity, chemical inertness, and it versatile. Mechanical flexibility and easily manipulated. So now I would like to share about what is photolithography. Process flow to build the microfluidic. First of all, we need to design the microfluidic device and then fabricate the microfluidic device using photolithography technique, then bonding the PDMS layer on the glass substrate or another silicon wafer using the O2 plasma bonding, and lastly the device testing to test either have leakage or not. Okay, now we go to the microfluidic device design. Okay, for design, use the AutoCAD software. So here the simple design. I just show you the simple design, which is the inlet here and outlet, which have a fluidic channel. So we transform it into the 4-inch design here. Okay. Then to verify the design, to verify the design, we can use the console multiphysics simulation to test either the channel width, the length is okay or not. Okay, for example, this one, I use the width 150 micrometer, the length and 5.5 millimeter. So from this simulation, we can see the air pressure drop from enter and outlet. So that's mean the fluid can flow through the channel until the outlet. And this one, the velocity is constant. So that's mean the design is okay to further for fabrication process. Okay, now go to photomask. Okay, what is photomask? Actually, for photolithography process, we need to have a photomask. So from the AutoCAD design first that we create first, then we send it to the shop and then we'll printing on the chrome mask. This is example of the chrome mask. I'm sorry I didn't have the chrome mask for microelectronic for microfluidic. So I just show you an example of chromas, how it looks like. So this chromas will use for the next photolithography to create the mold on the silicon sample. Okay, the next slide I will show you how to fabricate the device. Okay, there are two. First, the first step is the production of the developed pattern, which is mold for microfluidic. First, okay, because we based on semiconductor fabrication, so usually use the silicon substrate. It means silicon wafer. So first, silicon wafer is coated with the photoresist. For microfluidic photoresist, we use SU8 photoresist, the type of photoresist. And then the code sample go to photolithography process. Then for photolithography process, develop pattern. Okay, for the next slide, I will show you the basic principle how the photolithography process work. Okay, after we got the mold, next pour the PDMS layer onto the mold and then wait for a few hours. Then we can peel off the replica mold. Then the last one is the PDMS stamp. So the benefit from PDMS microfluidic is we by using the same master mold, we can produce a large number of PDMS replicants. So it's cost effective. Okay, this I will show you how the photolithography process work. Hmm. Wait, I think I need to. Okay, okay, this is the silicon sample, and then this photoresist will drop on the silicon and then coating the photoresist. Okay, this is the use of the chrome mask.